Hello, this is Let's Talk Climate. In this video, I'm going to talk about some new research that's come out on glaciers and their melting. The article is titled Global Glacier Change in the 21st Century. Every increase in temperature matters. And this article was just published in the Journal of Science, one of the top tier journals in the world. And it was just published in 2023. So I'm going to have a read through it, and I will give you my reaction to it and my thoughts on the key points and what it means. If you'd like to read the article, I've included a link in the video description. So first of all, what exactly is a glacier? A glacier is a persistent body of dense ice that is constantly moving under its own weight. And did you know that around the world, there's more than 215,000 glaciers? So before we dive into the article, why do we care about glaciers? Well, first of all, if all the glaciers on Earth melted, then we would see a significant increase in sea level rise. So that's what part of this paper is going to talk about. The other important thing about glaciers is that they have huge implications for the ecosystems adjacent to them. For example, we've seen in the news lately that the Colorado River has been drying up, and that's fed by glaciers on top of mountains. And also Lake Mead, which is fed by the Colorado River. Literally, people's sources of fresh drinking water are reliant on these glaciers existing. So what happens if they all disappear? So let's get into this article. What these researchers aimed to do was to produce a set of global glacier projections for every glacier on Earth based on the shared socioeconomic pathways, which are, the acronym is SSPs, from 2015 through to the year 2100. So to do this, they used huge data sets and very complex models that I'm not even going to try to explain to you. But what I will explain is that in 2015, there was the Paris Agreement, which was signed by 195 different countries. And they agreed to try to keep the increase in global mean temperature by the end of the 21st century relative to pre-industrial levels to below 2 degrees Celsius. And that there should be an effort to try to do even better than that to keep it below 1.5 degrees Celsius. This target was kept alive in 2021 during the Glasgow Agreement at COP26. To evaluate the sensitivity of glaciers to global mean temperature projections, they're going to use the 1.5 degree increase, 2 degrees increase from pre-industrial levels, 3 degrees, and 4 degrees. Under the scenario where temperature increase is 1.5 degrees, we're expecting that glaciers will lose between 20 to 32% of their mass by 2100. And under a 4 degree temperature increase scenario, they would lose between 30 and 62% of their mass relative to 2015. This mass loss would increase mean sea level by 90 millimeters plus or minus 26 under the 1.5 degree scenario, 99 millimeters plus or minus 31 under a 2 degree scenario. Under 3 degree scenario, we would expect 125 millimeters increase plus or minus 39, and under 4 degrees would be 154 millimeters plus or minus 44. What's interesting is that for the 1.5 degree scenario, the rate of sea level rise peaks in the year 2035, whereas for a temperature scenario of 4 degrees, it steadily increases past the end of the century. What's really scary is that even if global mean temperatures are kept below 1.5 degrees of warming, they still estimate that 104,000 glaciers, plus or minus 20,000 due to the uncertainty in the calculations, would disappear by the year 2100. So that's around 50% of the current glaciers under the best case scenario of keeping our warming below 1.5 degrees. And most of the glaciers that are currently less than a kilometer squared in area are expected to completely disappear. Even though these glaciers are small, they still have significant cultural value, tourism value, and have really big implications for local hydrology and for feeding the local rivers. What's interesting is that their model is spatial, so they could look at regional trends in the loss of glacial mass, and they found that Alaska will be the largest contributor to sea level rise if their glaciers melted. They also found that Greenland, Antarctic, and subantarctic, and then parts of Arctic Canada would contribute a significant amount as well. And in total, these regions would contribute around 60 to 65% of total glacier contribution to sea level rise. Western Canada and the US, South Asia, East Scandinavia, Northern Asia, Central Europe, low latitude areas, the Caucasus and Middle East, New Zealand, are all projected to lose between 60 to 100% of their glacial mass, depending on the different temperature projections. The authors continue to say that although these regions are not significant contributors to sea level rise, people in these regions will need to adapt to changes in seasonal and annual runoff, as the additional water provided by glacier net mass loss will decline before the year 2050. So these changes are going to happen much quicker than a lot of us think. Another important finding of this article is that the projected mass loss is linear related to global mean temperature increase. This strong relationship highlights that every fraction of a degree of temperature increase substantially affects glacier mass loss. Every fraction matters. Figure 3, I think, shows a good spatial representation around the world of what you can expect for the loss of glaciers in different parts of the world. The blue bars represent a 1.5 degree temperature scenario, followed by the yellow, the orange, and then the red is the worst case scenario of 4 degree increase. And so you can see after the year 2100, how much are they projecting for the different regions around the world would remain for the glaciers. Something also that was interesting, I thought, was that if glaciers have debris on them, and apparently a good percent of glaciers have a small amount of cover on them, that debris can actually slow down the rate of melting. In some cases, they said in New Zealand, for instance, some of the debris could have an insulating effect that reduces the net mass loss by 9 to 13%. However, later on, they say, essentially, although the debris delays the loss of ice, by the end of the century, it's going to have little impact because it's all going to pretty much melt. For comparing glacial loss to the different RCP scenarios, which basically RCP 2.6 scenario means a best case scenario in cutting CO2 emissions, where an RCP 8.5 scenario essentially means a business as usual, or almost like a worst case scenario. There's no change in emission reductions. Globally, we predict glaciers will lose 26% plus or minus 8 under the RCP 2.6 scenario, the best case, to 43% plus or minus 13% for the RCP 8.5 scenario. The authors concluded that every increase in temperature has a significant consequence with respect to glacier contribution to sea level rise, the loss of glaciers around the world, and changes to hydrology, ecology, and natural hazards. Based on the most recent climate pledges from COP26, global mean temperature is estimated to increase by 2.7 degrees Celsius, and this would result in a much greater contribution to sea level rise, around 115 millimeter increase, and near complete deglaciation of entire regions. The authors concluded with stressing the urgency of establishing more ambitious climate pledges to preserve glaciers in these mountainous regions. So overall, a pretty sobering article. There wasn't a lot of good news in it. There wasn't much discussion at all of solutions except to, at the end, to pledge to be more ambitious in cutting your greenhouse gas emissions. So what can we do about it? I think the number one most important thing is that our civilization needs to transition to a renewable energy future. So that means switching all of our electricity grids from fossil fuel power plants to completely clean energy generation like wind, solar, and whether that needs to happen at the power plant level or residential level, like for example, you putting solar panels on your own house, any of that will help. So ultimately cutting our fossil fuel consumption through transport and energy usage, and also the amount of waste we use. If we can purchase products with less packaging or eat food that comes from sources that require less energy to produce them, that all has huge impacts over time. So we all need to be part of the solution. So I really encourage everyone to try to do their part as best you can to try to reduce your emissions, share this with other people, and try to come up with solutions to remove that CO2 to get carbon negative. If you enjoyed this video, please hit the thumbs up button. It really helps the channel. And please consider subscribing if you want to see more videos about the science of climate change or new articles or news about it, and also innovative solutions to combating it and becoming more sustainable. Thanks for watching.